This is Mr. Collier, and today we're doing a proof by induction with this inequality involving surds. And we're going to start with the base case, which is n equals 2. And let's look at the left-hand side is going to be 1 plus 1 over root 2, and then the right-hand side is going to be simply root 2. So we need to compare these two quantities. I suppose you could use a calculator, but we could also do this algebraically. So let's add these together. We're going to get 1 plus root 2 over root 2. Now this side here we can write as root 2 plus root 2, which equals, well, divided by 2, because that's 2 root 2 divided by 2. So this is the same as this. Looks closer. We got a root 2 down here though, so let's get rid of that. And this is going to be root 2 plus 2 over root 2, or just 2, sorry. So now you can easily compare this, and we see that the left-hand side is bigger. Okay, left-hand side is bigger than right-hand side, since 2 is bigger than root 2. So we just compare those two parts. Okay, so that's a lot of work just to prove the base case. Now we're going to go on to n equals k. We're going to assume that 1 plus 1 over root 2 plus 1 over root 3 plus dot 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 plus 1 over root k is greater than root k for some k in the integers with k greater than or equal to 2. So we'll assume that, and let's take a look at our goal. Our goal is to get show that 1 plus 1 over root 2 plus and so forth 1 over root k plus 1 is greater than root k plus 1. So that's what we're looking for. Let's start with our assumption, as we often do in inequalities. So we have 1 plus 1 over root 2 plus 1 over root 3 plus, we're going to go all the way up to k, 1 over root k. That is greater than root k. Alright, so we want to add on this term here to both sides of the inequality. And we'll have this, maybe I'll write it like that. And over here we have root k plus 1 over root k plus 1. So on the left-hand side we have what we want, on the right-hand side we want it to look like this. So let's simplify and see what happens. Okay, this is equal to root k times root k plus 1 over root k plus 1 plus 1 over root k plus 1. We'll add those together, and we got root k plus 1 plus 1 over root k plus 1. Okay, so what we want to have on this side is just root k plus 1. So if we look closely at this, if we had on the numerator, in the numerator k plus 1, then we'd have k plus 1 divided by root k plus 1. We'd get root k plus 1 as required. And we can make that that happen. Because of this inequality, we have the right-hand side is less than the left-hand side. We can make this quantity on the left smaller if we want to, and the inequality still holds. So I can make this smaller by removing that 1 and just saying root k plus 1 over root k plus 1. Okay, so we can go as small as we want here on the right-hand side because the inequality will still hold. And just taking away that 1, we get what we want. We get k plus 1 over root k plus 1, which equals root k plus 1. And if you follow all of this, these lines here, what we have now is that this quantity is greater than root k plus 1 as required, right there. So we can write that in the final line of this part. So therefore, 1 plus 1 over root 2 plus dot 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 plus 1 over root k plus 1 is less than less than or greater than? It's greater than, sorry. Yeah. It's greater than root k plus 1. So we're done with the proof. You just need to write a sentence now. Since the result is true for n equals 1, or in this case it was 2, and since n equals k, true implies n equals k plus 1 is true, then we have 1 plus 1 over root 2 plus 1 over root 3 plus dot 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 plus 1 over root n is greater than root n for all n in the integers such that n is greater than or equal to by the principle of mathematical induction.